Class 6. How are you all? So, we have been studying chapter number 10, motion and measurement of distance. So, last time we studied about the different type of motion. Yes. Today we will study about a new motion, that is oscillatory motion. Yes, oscillatory motion. Okay, or oscillatory motion is also, you can call it vibratory motion. Okay, oscillatory motion is also actually a vibratory motion. Okay, so in oscillatory motion, check out the spelling of oscillatory motion: OSCILLATORY, oscillatory motion. So uh, these kind of object do the oscillation. Yes, oscillation, OSCILLATION, oscillation. Okay, so what is the meaning of it? What is the meaning of oscillatory motion or oscillation? What is it? The back and forth movement, the backward and forward movement of any object is known as oscillation. Yes. So, kids, you might have seen the pendulum of a wall watch of the that we hang on the wall, watch that we hang on the wall. So, you might have seen that the pendulum of watch moves like this. Yes, go up, down. It goes back, forth, back, forth, back, forth. It goes forward, then backward. Forward, backward means forth, back, forth, back. So it looks like coming, going, coming, coming, going. So this kind of motion, which is repeating again and again and again in a fixed interval of time, is known as oscillation or oscillatory motion. Yes, oscillation or oscillatory motion, or you can also call it vibration, or you can also call it vibratory motion. Okay, because vibration is also a back and forth movement. Vibration is also a back and forth movement. Okay, so when a body moves to and fro about a fixed point is said to be oscillatory motion. Yes, when a body moves to and fro about a fixed point is said to be oscillatory motion. As you can see, kids, as you can see in the picture, the kids are playing with the kids are playing with the kids are sitting on the swing. The kids are sitting on the swing. Yes, and they are playing. Yes, the kids are sitting on the swing and they are playing. So look at the motion. Look at the motion of these kids. They are going forward, then backward. Forward, backward means fro, back, fro, back. So when a body moves to and fro about a fixed point, it is said to be oscillatory motion. To and fro means backward, forward, backward, forward. Okay, and all musical instrument, when you play musical instrument, it start vibrating means it goes to fro. So such motion is the motion of instrument is known as vibratory motion. Yes, well, both are same, because in vibratory motion also to and fro goes, and in oscillatory motion also to and fro happen. Okay, so but the vibratory, whenever anything is vibrating, it actually very fast to and fro motion. Yes, all the musical instrument shows vibratory motion. Yes, all the musical instrument shows vibratory motion, and during this motion a change in shape, size can take place. Okay, I hope you understood. Okay, so sometime actually the whole object doesn't show the motion. So in vibratory motion, the whole object not showing the motion. Okay, whole object is not showing the motion. Okay, so that may be a little bit difference between oscillatory motion and vibratory motion, but otherwise both are same, because vibratory motion is to and fro motion, oscillatory motion is also to and fro motion. But in vibratory motion all object does not show to and fro motion, but in oscillatory motion all the objects show to and fro motion. But if we talk according to your book, according to your book, it is also a vibration of guitar, playing music on any instrument, like tabla, okay, guitar. So this shows the oscillatory motion, or you can say this shows the vibratory motion. Okay, I hope you understood. Now, kids, let's talk about a new kind of motion, that is periodic motion. Okay, but before we talk about the periodic motion, kids, let's revise whatever we studied, because revision is very important, as you know. So first of all, let's revise the translatory motion. Okay, because revision is very important. So what is translatory motion? The motion in which all points of body, the motion in which all points of a moving body, they uniformly, all the points are actually uniformly along a straight line. That is known as translatory motion. So translatory motion actually can be divided into two parts: rectilinear motion and curvilinear motion. Yes, rectilinear, rectilinear, curvilinear, curvilinear. So what is rectilinear motion and what is curvilinear motion? So if a body, let's talk about rectilinear motion. If a body moves in a straight line, if a body goes in a straight line, it is called rectilinear motion. But if a body moves along a curved path, then it is called curvilinear motion. You know, march past of soldier, you might have seen, you might have done in your school march past. So it shows the curvilinear motion. Yes, it shows curvilinear motion. Yes, so if a body moves along a curved path, then it is said to have curvilinear motion. But if a body moves in a straight line, it is called a rectilinear motion. Now kids, let's talk about the circular motion. What is circular motion? An object is said to be in a circular motion when it moves around a fixed point called axis. Yes, an object is said to be in a circular motion when it moves around a fixed point. Yes. So a curvilinear motion can be divided into two parts: revolution and rotatory motion. Yes, revolution and rotatory motion. So what is revolution? When a body as whole moves around a circular path, then its motion is called revolution, and the body is said to be revolved. For example, the motion of earth around the sun, the motion of moon around the earth. Now let's talk about rotatory motion. So when any body undergoes translatory motion in such a way that its part cover different distance, they also move in a round and round, but all the paths will cover the different distance. Yes, rotatory motion is a motion in which all the paths cover different distance in a given time, is known as rotatory motion. But what is revolution motion? When a whole body moves in a circular path. Okay, but in rotatory motion, the different paths cover the different distance of a body in a given time. It is said to be a rotatory motion. For example, rotation of the earth, in which axis cover the different distance, the equator cover the different distance. Yes, Cancer and Capricorn cover the different distance. So even the windmill is also the example of rotatory motion. If someone is dancing on one leg and moving round and round, then it is also the example of rotatory motion. And kids, we also studied about the random motion. Yes, what is random motion? Irregular motion of a body. Irregular motion of a body in which the direction is not fixed. Yes, irregular motion of a body in which the direction is not fixed. Direction is not, that is known as random motion. For example, while playing the football, when we kick the football goes in different direction, which is actually irregular motion, because the football can go in any direction. And butterflies fly, then they show the different direction, which is actually a random motion. I hope you understood. Now kids, let's study about one more motion. Let's move on the next point. Okay, it's periodic motion. Okay, so when the same motion repeat itself, yes, when any motion is repeating again and again and again and again after equal interval of time. Yes, time should be equal interval, time interval should be same, time interval should be same, then we will call it periodic motion. Yes, so what is periodic motion? When the same motion, when the same motion repeats itself, when the same motion repeats itself after equal interval of time, we call it periodic motion. Yes, when the same motion repeat, if the motion is repeating again and again after equal interval of time, then we will call it periodic motion. Yes, I hope you understood what is periodic motion. Okay, when the same motion repeat itself after equal interval of time, we will call it periodic motion. For example, as you can see, the earth revolve around the sun. Yes, earth cover one circular motion in around 365 days, then after 365 days it again cover. Yes, then it again in next year, then in next year, so it covering again and again, and it is moving with the same speed. Even you know that the earth rotate on its own axis. Yes, the earth rotate on its own axis, so it takes 24 hours to complete one oscillation. It takes 24 hours to complete one oscillation. One oscillation means time taken. It takes a fixed time period. It takes a fixed time period. So time period means what? Time period means one time taken to complete one oscillation is called time period. What is time period? Time taken to complete one oscillation means one round. Okay, so earth takes 24 hours to complete one oscillation. So after 24 hours, earth again start rotating, and after 365 days, earth again start revolving. Okay, so we can say the earth not only rotate but also revolve. Okay, and look, one more picture I have shown, that in the watch, the needle, second needle moves, minute needle also move, and hours needle move. So you know that second needle, if we talk about the needle which shows the second time in seconds, so that needle repeat its motion after 60 seconds. Yes, after each 60 seconds it rotates its motion. And if we talk about the minute needle, it will also rotate its motion, but after every, when it will rotate its motion? Yes, after, tell me, after, okay, now let's try to understand this topic, objects or actions having more than one type of motion. Objects or action having more than one type of motion. So kids, some action shows the many type of motion, and some object also shows the two or more than two type of motion. Okay, so as you can see in the picture, can you see the picture of a well? WELL, well. So as you can see, the pulley, through the pulley a bucket is hanging. So the in case of pulley will rotate. Yes, pulley will rotate. So pulley is showing rotatory motion, or you can say pulley is showing the circular motion, because in this case the pulley on which rope is put has circular motion. And when you will try to deep the bucket with the help of rock using pulley, when you will try to deep to draw the water from the well, hanging the bucket with a rope using a pulley, then what will happen? The bucket with the help of rope, if you will use the pulley, then the bucket with the help of rope, it will go straight, so it is showing the rectilinear motion also. So the bucket is showing the rectilinear motion with the help of pulley and rope, and the pulley itself showing the motion circular motion, which is you can also call rotatory motion. Okay, which you can also call rotatory motion. So what is rotatory motion? Is when a body undergoes translatory motion in such a way that its part cover different distance in a given time, it is said to have rotatory motion. Okay, and linear motion, you know that when a body moves in a straight line, it is known as linear motion. Okay, next example, as you can see the next picture, can you see swing machine? Then yes, this is swing machine. So in swing machine you might have seen the needle when you needle goes up and down, it goes up and down, yes. So it is going to and fro, backward forward. So the needle is going. When you hold the handle of the swing machine, and when you rotate it, then the needle will move to and fro. When you will hold the handle and move it round and round. When you will move it round and round handle, then the needle will go up and down, to and fro, and the wheel attached with the handle, it will rotate. So it is completing the circular motion, and the wheel is showing the circular motion, or you can say the wheel is showing the rotatory motion, and the needle is showing the oscillatory motion. Yes, because to and fro motion is known as oscillatory motion. Yes, or you can say vibratory motion, because the whole body is not moving, only needle. And I hope that you understood. And also the frisbee, in this frisbee has rotational motion as well as linear motion in the direction it moves. I hope you understood. Now let's see some more examples of motion. Okay, let's move on the next point. Okay, it's many types of motion. So first of all, motion of the earth. So as you know that earth revolves around the sun. Yes, earth revolves around the sun, thus showing circular motion. Yes, so when the earth revolves, earth takes 365 days, about 365 days to complete one circle, one complete round. So earth revolves around the sun, and it is showing which motion? Circular motion, or you can say revolution. Yes, and when the earth rotates on its axis, it shows the rotatory motion. So both the motion are repeated after a fixed interval. So you know that earth shows the revolution and rotation. Earth shows both, but the point is above these two motion, we can also say both the above motion, because the earth after 365 days, it again shows the motion, means it again complete the round, and after 24 hours on its own axis, it again complete one round. Then after 24 hours, it will again complete one round. So it will go one round, two round, three round, and continue. So it's showing periodic motion too. So we can say the earth not only have revolution motion, rotatory motion, but it also shows the periodic motion. So mainly two type of motion of the earth, periodic motion and circular motion. I hope you understood this one. Now kids, let's talk about the next is bicycle. Bicycle. So when a person ride a bicycle, when a person ride a bicycle, the cycle and the rider both shows translatory motion, whereas the wheel shows the circular motion, whereas the wheel shows the circular motion. Yes, you know, if you are sitting on the bicycle and you are riding the bicycle, then bicycle will go straight, and you are also going straight. You are also going straight, and bicycle is also going straight. Means you are showing which motion? Rectilinear motion. Yes, the motion in a straight line is called rectilinear motion, or you can say it is translatory motion. Okay, but the wheels are rotating round and round, so they are showing circular motion. Okay, next example is screw. You know, you use a screw for nuts. Yes, nut and bolt. So when to tight them, you use a screw for nut and bolt to tight them. So when a screw is screwed in a box, yes, when you move the screw, when a screw is screwed in a box, it shows both motion, rectilinear motion and rotatory motion, because the screw goes straight and also it is moving at its own axis about a fixed point. So we can say it is showing the rotatory motion also. Okay. So guys, let me tell you that 2 points I want to explain. Screw, the example of screw shows that rectilinear motion can be rotatory motion, but rotatory motion cannot be rectilinear motion. Okay, rectilinear motion can be rotatory motion, but rotatory motion cannot be rectilinear motion. And a periodic motion is always oscillatory motion, but oscillatory motion cannot be always periodic motion. Yes, remember, periodic motion is always oscillatory motion, but, or you can say periodic motion is a circular motion. Oscillatory motion, not, my mistake here. Oscillatory motion, not circular motion. Okay, a periodic motion can be circular motion. But circular motion cannot be always periodic motion. Yes, a periodic motion is always circular motion. But circular motion cannot be always periodic motion. Okay, remember these points. I hope you understood. Now let's move on to the next point. Okay, it's time to ask question from you. So as you can see the question on your screen. Question number 1. Can a periodic motion be oscillatory motion? Give an example. Yes, the periodic motion is always it's a circular motion. Okay, my mistake I have. So can a periodic motion be a circular motion? Yes. Can a periodic motion be circular motion? Yes. The periodic motion can be circular motion. Yes. A periodic motion is always a circular motion. A periodic motion is always a circular motion, but the circular motion is not always a periodic motion. Okay. So you know that motion of the earth revolve on its own axis, and it complete one round in 24 hours. So it shows the circular motion, which is actually a rotatory motion. Okay, but after 24 hour it is again completing the round, then again it will complete. So it is repeating its motion, then so it's repeating its motion, so we can say it is a circular motion is which is showing actually a periodic motion. So we can say the periodic motion is circular motion. But uh, circular motion cannot be always periodic motion. Okay, circular motion cannot be always periodic motion. Okay, and kids, oscillatory motion, if oscillatory motion can also be a periodic motion, oscillatory motion can also be a periodic motion, because if something is going to and fro and repeating again and again and again, then it is also a periodic motion. Next question, what is oscillation? Yes, what is oscillation? Oscillation is also known as oscillatory motion. Oscillation is also known as oscillatory motion. So when a body moves to and fro about a fixed point, it is said to be oscillatory motion. When a body moves to and fro, when a body moves to and fro about a fixed point, it is said to be oscillatory motion. So remember kids, circular motion can be periodic motion, okay, but periodic motion cannot be circular motion, okay, and oscillatory motion also can be periodic motion, okay, oscillatory motion can also be periodic motion, but periodic motion always cannot be oscillatory motion. Okay, now question number 3, define time period. So what is time period? Time taken to complete one oscillation is known as time period. Time taken to complete one oscillation is known as time period. Question number 4, give any example which shows more than one type of motion. Yes, which example shows more than one type of motion? For example, bicycle. Yes, when a person ride a bicycle, the cycle and rider goes straight, which is actually a rectilinear motion, but the tires are rotating, so it is actually a circular motion. In the same way, drawing water from well, in this case the pulley on which the rope is put, so the pulley will show circular motion and the bucket will go straight, so it will show linear motion. Okay, I hope you understood. Now in next class we will study about the measurement. Now the motion topic is completed. Now we will start a new topic of this chapter, of the same chapter topic we will start, that is measurement, in next class. Okay, so till then keep patience.